Well, good day and welcome back to the Johnson Space Center for the preview of the next 2 expeditions to the International Space Station. This is the ISS mission and science overview briefing to look at current events on the station and to look at expeditions 33 and 34, which will span the time frame from September 17th of this year through March 19th of next year. With us today to discuss all of that are Dan Hartman, the International Space Station Manager for Operations and Integration, Chris Edelin, the lead flight director for Expedition 34, and Dr. Julie Robinson, the International Space Station Program Scientist. And we'll start off with Dan.
All right, thank you, Rob. Good morning, good afternoon, everybody. You know, I think we're in an almost unprecedented area of vehicle traffic to the International Space Station presently. Our teams across the partnerships are doing an outstanding job continuing to plan and execute the various missions that are behind us and the ones that we have coming up. You know, last Monday we increased our crew size to a crew of 6 with the successful 31S docking. On the 22nd, we undocked 47P. 47P met all of its mission objectives as far as unloading cargo, doing propellant transfers, reboost, taking away trash for us. And I'll talk about the status of the undock here in a second. Tomorrow morning, we'll be on track to capture HTV-3. The vehicle looks very, very healthy. I believe that capture time is around 7 a.m. We'll be bringing that into the Node 2 nadir berthing port, carrying about 2,300 kilograms of pressurized cargo for us and a couple of external payloads that will be taken off the pallet and installed on the space station. For 47P, we have been, the progress has been experiencing some issues with their new Coors NA system that they installed while they're on orbit. Right now, they continue to work through those. They've tried, I'd say, 5, 6, 7 times to run a self-test on the box itself. It seems to appear to be getting hung up in that sequence somewhere. Yet some of the parameters, or most of the parameters that they're receiving off of that box, they can also see, and they look perfectly healthy. So it's failing a self-test, not getting all the way through it, but the avionics box itself appears to be healthy. And so what we plan to do is take one more attempt of bringing that in on Saturday. I believe it's Saturday evening. They'll come into 46 kilometers, and then we will try to activate the NA system. If we get good range rate, the box looks healthy, we'll continue to press in for the docking. If not, I believe the plans will be it'll abort and finish its mission associated with the space station, and I think it stays in free flight for several more days to carry out some secondary payload objectives. So if we are successful with that docking on Saturday night, then the plan would be to undock it on Monday, which is, I believe, the 30th. To make room for the 48P launch, which happens August 2nd. And again, we'll use the port vacated by 47P, the DC-1 nadir. And that 48P is implementing the new, a test run of the new 4-orbit rendezvous that Energia and Roscosmos has proposed. We still have some work to do on that as far as a final go, no go, but you know, as long as the station stays in kind of a stable attitude where it is, I think they have the plans in place to be able to carry that off. And so I would tell you that's our baseline now, but there's just a little bit more work to do on that. Looking ahead, we got 2 EVAs planned in the August time period. Mid-August, we have a Russian EVA. That'll primary objective is to deploy and attach the service module extra debris panels. That'll help our MMOD protection. And then we have an EVA later, a U.S. EVA later in August to deal with our MBSU 1 that we plan to R&R. We'll lay some MLI cables as well and put a cover on our PMA2 adapter. Looking ahead, we have SpaceX currently planned, SpaceX 1, the first CRS mission planned for 10/5, and right now we're tracking orbital demo mission for December 12th. Consumables-wise, we remain in great shape. I think if we looked at food and water, without the vehicles that are coming to us, we're good until you know, like March, April time period. Water, obviously, we're kind of unlimited as long as our water processor system works. So when I talk water, consumables. That's if we experienced a failure. Almost immediately, we're still good through the March time period. And then when we get HDV3 in, that'll just make us more healthy. And we continue to focus our 35 hours a week on research. We've got a lot of external payloads that are performing the great science for us as well, and I'm sure you'll hear more about that from Julie here in a second. And with that, I'll turn it over to Chris.
Okay, thank you, Dan, and good morning, everyone. For my portion of the briefing here, I'll be reviewing the major events during Expedition 33 and 34, including vehicle traffic as well as the crew rotation schedule. So let's start with the first graphic, which shows the current crew on board the space station. This is the crew of Expedition 32, and this consists of 2 Soyuz crews, and the crewmen located in the lower right-hand side of the screen are the 30S crew, and they are scheduled to return to Earth on September 17th. That's Joe Acaba, Gennady Padalka, and Sergei Revin. And so when they depart from the station middle of September, that will begin Expedition 33, and it will leave the crew on the upper left there as the sole occupants of the space station for the first 4 weeks. Now that crew on the upper left, that's the 31S crew. As Dan just mentioned, they just arrived on station last week. They're settling into their new home and already jumping into the research as well as preparing for HTV birthing, which is tomorrow. So let's meet the individual crew members. First is AKIHIKO HOSHIDE. He's an astronaut for the Japanese Space Agency. He has an aerospace engineering background, and he was selected as an astronaut in 1999. He previously flew on shuttle mission STS-124, which delivered the big Kibo Japanese experiment module. Next is YURI Malenchenko. He's a colonel in the Russian Air Force with a very extensive flight history. He first flew in space to the Mir space station back in 1994. He performed 2 spacewalks on that mission, and then he next flew on shuttle mission STS-106, which was an early outfitting flight for the space station, and he performed 1 spacewalk on that mission. Then he was the commander of Expedition 7 back in 2003, and he was flight engineer on Expedition 16 in 2007. And this current mission, Expedition 32-33, is his 5th space flight. And Yuri is also the commander of the 31S Soyuz spacecraft. And rounding out the crew is Sunita Williams. She is a captain in the U.S. Navy and formerly a helicopter pilot. She was selected as a NASA astronaut in 1998 and previously flew to the space station on Expedition 14 and 15 back in 2006 and 7. And she performed 4 spacewalks on that mission. And she will be the commander of Expedition 33. So the first cargo vehicle task for Expedition 33 will be the undocking of the European Automated Transfer Vehicle, or ATV-3, known as Eduardo Amaldi. It will be undocked from the aft end of the Zvezda service module on September 25th. And this shows a graphic of the ATV approaching the space station. So the ATV-3, it arrived back in March, and it delivered oxygen, water, about 2.5 tons of dry cargo, as well as enough propellant to lift the station to its highest orbit that it's ever been, which is 400 kilometers, or about 250 miles. So prior to the undocking of ATV-3, the crew will be loading trash into it, and then Yuri and Aki will actually perform the undocking, and then it will be disposed of during reentry over the ocean. The next task for the crew, the next vehicle task will be the arrival of SpaceX-1, our next Dragon mission that's currently planned for October 7th. This graphic shows the Dragon spacecraft from the demonstration mission back in May, but the one planned for Expedition 33, SpaceX-1, is the first commercially contracted resupply flight of a Dragon. So in the days leading up to this, Sunny and Aki will be practicing using the big Canadarm2, the robot arm on station, to perform the tricky grapple maneuver. And then on the day of birthing, then the Dragon will come up and hover beneath the station. They'll grab it with the robot arm and maneuver it to the Node 2 or Harmony node, the Earth-facing port shown in the graphic there with the Dragon. And then they'll mate the electrical and data connections, as well as some air ducting, and the following day they'll open the hatches and then initiate about 24 days of cargo transfer operations. And some of the noteworthy cargo that's coming up on SpaceX-1 is a new Japanese plant experiment known as Resist Tubule, as well as a glacier refrigerator that's used to keep science samples, biological samples cold for the return to Earth. NanoRacks, which is a modular payload rack that's coming up to the station, as well as the usual resupply equipment such as food and clothing for the crew and spare parts for the station. Next big event for Expedition 33 will be the arrival on October 17th of the 32S Soyuz crew, shown in the right-hand side of this portrait of Expedition 33. So let's meet the individual crew members, starting with Kevin Ford. Kevin is a retired colonel from the U.S. Air Force. He's a former test pilot. He was selected as an astronaut back in 2000, and he previously flew as pilot on shuttle mission STS-128, which was a logistics flight to the space station. And Kevin will be the commander of Expedition 34. Our Soyuz commander is Oleg Novitsky. He's a colonel in the Russian Air Force. He's been a cosmonaut since 2006, and this will be his first space flight. And rounding out the 32S Soyuz crew is Yevgeny Tarelkin. He's a captain in the Russian Air Force, and he's been a cosmonaut since 2003, and this is also his first space flight. And in addition to the three humans that'll be coming up in October, we'll also have 32 Medaka fish, which are on the Soyuz, which will be destined for the aquatic habitat, which is a scientific fish tank that will be stationed in the Japanese module. That's being delivered actually tomorrow by the HTV-3, which is coming to the station tomorrow. This will be used to study the effects of microgravity on the fish, especially their skeletal systems and how they evolve over multiple generations in space. And Julie will have more details on that in just a few minutes. Another important work that we'll be doing with the beginning of the 32S crew time on station is taking the baseline physiological measurements, which are very important to establish the initial conditions, and then we can study how the long-term exposure to weightlessness and the space environment affects the crew's physiology. And we have all types of measurement devices on the station, including an EKG, an ultrasound machine. We measure the oxygen uptake when they exercise, as well as take blood, urine, and saliva specimens, and again, to study their bone and muscle loss, as well as changes to their immune system while they're in space. So this will be a busy time after the 32S crew arrives. They'll also be finishing up the cargo transfer operations with the Dragon. The Dragon will be undocked on October 31st, and this is a short sequence to show you how we undock a Dragon. This is from the demo mission. First, the crew grabs it with the Canadarm2 and releases the bolts from the station node. Then the arm maneuvers it below the station, and the crew commands the release of the arm, and they back away. And as they're doing this, the SpaceX mission control team in Hawthorne, California, activates the spacecraft guidance and control systems, and then we'll perform the series of back-away maneuvers, and several orbits later, we'll deorbit the spacecraft for a landing in the ocean off the coast of California, and at which point they will retrieve the science samples and other returned hardware from SpaceX Dragon. Okay, moving on. A few days later, on November 3rd, we'll have a new Progress vehicle arrive at the station, the 49P vehicle. It's the Russian unmanned supply ship. It will dock to the aft end of Zvezda service module, where it will remain for about 4.5 months. And then the next event is October 12th, when the 31S Soyuz crew with Sunny, Yuri, and Aki undock and return to Earth. They're shown there in the lower right-hand corner. So they'll return to Earth after their 4-month stay on the station, and then Kevin Ford will take over as commander of Expedition 34, and will begin another 4-week period with just 3 crew members on station. And then at the end of that period, on December 7th, is when we expect the 33 Soyuz crew to arrive. And here you see a portrait of the Expedition 34 crew. and our new crewmen are shown on the right-hand side of this photo. The crew on board 33S are Tom Marshburn. He's a NASA astronaut and a medical doctor. Before becoming an astronaut, he was a life flight physician and an ER doctor before he came to work at Johnson Space Center as a flight surgeon. And he was selected as an astronaut in 2004 and flew on shuttle mission STS-127 back in 2009, which delivered the Japanese external facility. And he performed 3 spacewalks on that flight. And this will be his second trip into space. Next is Chris Hadfield. He is a retired colonel in the Canadian Air Force and a former test pilot. He was selected by Canada to be an astronaut back in 1992. He also has an extensive flight record. He flew to the Mir space station on STS-74 back in 1995, and he was a mission specialist on shuttle mission STS-100, which delivered the Canadian robot arm to the station in 2001. And he performed 2 spacewalks on that flight to assemble and attach the arm to the station. And Chris will be the commander of Expedition 35, making him the first Canadian to command a spacecraft. And then rounding out the crew is our Soyuz commander, Romanenko. He's a major in the Russian Air Force and selected as a cosmonaut in 1997. And he previously flew to the station on Expedition 20 back in 2009. And his father, Yuri, is also a cosmonaut. So again, after the 33 Soyuz crew arrives, first order of business, as before, will be to take those baseline medical measurements for the crew, as well as to prepare for the next cargo vehicle arrival, which is scheduled for 10 days later on December 17th. They will be training to perform a similar maneuver as with the Dragon. On December 17th, there will either be a Dragon or an orbital Cygnus vehicle that will arrive. We're holding that date for either of those 2 vehicles, and it's to be determined by the station program working with with SpaceX and with Orbital to determine which vehicle will be ready for that mission in the middle of December. So again, we'll have another future press conference on that one to discuss that visiting vehicle plan. But for now, we're holding the spot in the crew schedule, and the training is very similar regardless of which vehicle arrives, and we'll make sure the crew and the vehicle are ready when the decision's made based on which vehicle will be scheduled in December, and then presumably the other vehicle will be early 2013 based on the launch vehicle readiness. So as before, while the commercial vehicle is docked to station, we'll be doing the cargo transfer operations. And then on December 29th, if it's the Cygnus vehicle, it will undock, and we have a graphic to show you the Cygnus vehicle in free flight. Or if it's a SpaceX Dragon, the undock will be, or unberthing will be on December 16th. So after the visiting vehicle ops, we'll have a full complement of 6 crew. We will ramp up our research objectives taking advantage of the full crew size. We'll also be trying to do some improvements to station during this early 2013 time frame. Some of those include we're going to overhaul the U.S. toilet. We're also going to replace a heat exchanger in the airlock. And we plan to upgrade our high-rate comm system, our big dish antenna system, the internal avionics. We're gonna install a solid-state video recorder. We're gonna make some other avionics improvements that will basically double our downlink bandwidth, increase our number of standard def video channels from 4 to 6, and add 2 new voice channels on our KU system. So again, lots of things for both research as well as station systems maintenance during that time frame. There's also a few more visiting vehicle operations to tell you about towards the end of increment or Expedition 34. In late December, the 48P Progress vehicle will undock from the Piers docking compartment, and it'll be replaced by the 50P Progress, which will remain until February, when it will be replaced by the 51P Progress. And then also in March, the 49P Progress will undock from the aft end of the Zvezda service module, and eventually it will be replaced by the next European automated transfer vehicle, ATV-4, which is tentatively scheduled for launch in April of 2013. And so for the last graphic there, Expedition 34 will end on March 19th, when the 32S Soyuz crew, shown in the lower right-hand corner, undocks from the station and returns to Earth after their 5 months in space. And that's when we'll transition to Expedition 35 with Chris Hadfield in command of the station. So I'd like to conclude just by mentioning the crew's motto for Expedition 34 is "From the Earth, for the Earth," which captures the goal of this mission and all the space station missions, which is to perform research that's not only advances space science and helps us develop space technology, but is really rooted towards or geared towards improving the lives of those on Earth, especially in the fields of medical science and understanding, improving our understanding of how the human body functions, as well as material science and fluid dynamics that have lots of applications for industrial processes on Earth. So that's sort of an intro for Dr. Robinson. I'll let her fill you in on more of the research details for the expedition.
Thanks a lot, Chris. Expedition 33 and 34 really represent the beginning of the second year of the full research mission of the International Space Station. We think of that as sort of our era of research that began after assembly was complete. And one of the transformative things that we've seen over the last year is the ramp up in the numbers of investigations going on at any one time. During this 6-month period for Expedition 33 and 34, we'll see over 198 experiments active on the space station with hundreds of participating scientists across the entire partnership and around the world. Of those, about 81 will be NASA investigations with NASA principal investigators, but many of these have additional international collaborations included. And those disciplines cover a broad range, probably broader than any other laboratory or any other national laboratory in the country, from human physiology, biology and biotechnology, physical sciences, earth and space sciences, technology development and demonstration, and education. And of course, I can only talk about just a tiny selection of those 200 investigations today. Over the years, especially the last 2 years, we've really moved into the second phase of our human physiology research that's really focused on how to keep crew members healthy when they're living in a weightless environment. In that weightless environment, their muscles can atrophy, their hearts can atrophy, they lose a lot of bone. And from our early ISS investigations, we learned a lot about those processes. Those have let us move on to a phase of testing, and we're really seeing differences in the health status of crew members when they return as we move through those experiments. So I want to talk briefly about just a couple of those investigations that show what this second phase is like. One of these we call SPRINT, which is an experiment looking at how we can do higher intensity, lower duration exercise and still maintain bone and muscle. And here you see a picture of Dan Burbank using the Advanced Resistive Exercise device, which you can think of as a high-tech squat machine on the International Space Station. So balancing the way we use that machine as well as our treadmill helps us to get the most efficient exercise that we can to maintain bone and muscle and cardiovascular health. It's kind of not surprising that maintaining cardiovascular health and fitness is a core to the health of crew members on orbit. And as we learn more about those processes, they do give us insights into our health on Earth as well. Integrated cardiovascular is another investigation that is ongoing on the space station right now and will continue in Expedition 33-34. We're almost done with that activity. And it was the first comprehensive survey of how the heart is responding to the deconditioning from being in space. And in particular, here you see a crew member giving and receiving a cardiac ultrasound to look at the structure of the heart. We also do heart monitoring, Holter recording, and have learned a substantial amount about how the heart deconditions and how that is prevented by exercise programs. We also need to understand the core fitness of our crew members in orbit, and to do that, we use a technique called VO2 max, which is basically looking at the maximum oxygen uptake that a crew member has when they're exercising at their peak loads. And here you can see a picture of Mike Fossum participating in the VO2 max experiment on orbit. And this is another activity that will be ongoing in Expedition 33-34. So these are kind of the core of the advances that we've made to really understand how to keep the body fit and still how to minimize the time that we spend doing that so that we can maximize our research mission. We work with our partners in sharing the crew as human subjects, and there are some pretty interesting ESA investigations that will be ongoing in Expedition 33-34 as well. Our European colleagues, especially led by some scientists at Charité Hospital in Berlin, have developed a method of monitoring core body temperature that's much more accurate than anything used to date. It involves a sensor placed on the forehead and then another sensor placed upon the chest. And these are used on Earth now because of their value both in monitoring neonatal patients, babies in neonatal ICUs, as well as monitoring patients while they're having certain kinds of surgeries where their body has been cooled down, such as heart surgery. So these have had important applications on Earth. What scientists are interested in studying on the space station is how we can understand the thermal properties on the human body in space. And if I could have this heat stress graphic, this summarizes why being in space is so different in terms of the thermal load on your body. On the left is your body on the ground where you've got convection and warm air rising and carrying that heat away from your body. And on the right is a representation of what can happen in space. If you don't have enough airflow to help carry that heat away from you, you can really start building a more solid core body temperature. So the European Thermal Lab experiment looks just at body temperature to get basic information, since this has never really been measured before. The new investigation they'll be starting in Expedition 33-34 is to also use this core body temperature as a measure of circadian rhythms. Circadian rhythms are those diurnal rhythms that we all have where we get sleepy at night, we sleep, we wake up, we feel more alert, and there's a cycle of body temperature that goes along with those same diurnal cycles. And of course, those are regulated for us by the sun. So crew members in orbit, they don't have the thermal convection that we expect to see, and they don't have the sun rising every day and setting every day. Instead, they're going through multiple sunrise and sunsets inside a closed environment. And so this study will be the first to really look comprehensively at how the thermal patterns help us understand the circadian rhythm disruption. That has good basic science value, but it also will help us in managing mission operations better, particularly when we need to do sleep shifts or when we need to do other things and make sure the astronauts are at their peak alertness for a difficult mission activity. We also use model organisms to help us understand processes in studies that we really couldn't do on humans. And Chris mentioned one of those because there's a new aquatic habitat being launched by the Japanese Space Agency to the ISS. And their first set of studies will be an experiment called Medaka osteoclast. It will use the Medaka fish in this aquatic habitat incubator, and it's going to be focused on the cellular processes of bone loss. So here you can see a picture of a Medaka fish, and the osteoblasts are the cells that build bone, and the osteoclasts are the cells that remove the bone. Here in this image, you can see that using fluorescent protein techniques, you can actually build into the fish the ability to visualize whether those osteoclasts are building bone or resorbing bone, or whether the osteoblasts are building bone. And so this allows us to get insight into that dynamic process of bone remodeling. Bone remodeling is fundamental to osteoporosis here on Earth, because women that have osteoporosis have that bone remodeling essentially out of balance. And it's absolutely necessary to keep remodeling your bone or your bones become brittle. So these are really important core physiological processes that can be studied using these fish. There will also be studies going on in Expedition 33-34 using model plants. And these are now also in their second phase based on what was learned early in ISS utilization. So one of the things that we can study in space using our EMCS facility is the growth of plants. And here you see some results from the TROPY investigation done in the past on ISS. These plants are pointing or growing toward red light without any other stimulation. So there's no gravity stimulation, which plants can sense, and there's no blue light stimulation, which plants can sense. And this allowed investigators to determine or separate out these three different processes and understand which genes controlled each one. It also allowed them to do studies with partial gravity, which are quite interesting to see if in 1/6G, say on the moon, how would a plant be able to know which way to grow up, and how would a shoot be able to know which way to grow down. Also, they can do studies using 3/5G, which would be the equivalent of a Mars gravity. And so we'll have the follow-on set of these investigations, which going on over the next year, which is a set of experiments called seedling growth. You'll see seedling growth 1, 2, and 3. And it's a collaboration between US investigators as well as European investigators to share our centrifuge hardware and do a series of follow-on studies that build on the results of TROPY in the past to understand at a very fundamental level how plants grow. But it's also very important because it helps us understand the stress responses of plants, and those can have important applications back here on Earth for crop health and other horticultural studies. I'm going to shift gears from living things then quite dramatically to talk about a technology demonstration on ISS that you may have seen ongoing on NASA TV sometimes. One very visible technology demonstration going on over the last year and continuing in Expedition 33-34 will be the Robonaut study. And here you can see a picture of Robonaut. This is really a springboard that is very flexible and can be used to evolve new robotic capabilities in space. And by adapting and learning over time, as we learn how to program and control this robot and complete tasks, it gives us the opportunity to really start having robots work cooperatively with humans in space. In this video, you saw the R2 robot working with a task panel where it can show that it can rotate a valve, that it can position a needle valve, it can essentially push a button. And everything that you're seeing here is being controlled by operators on the ground, not by the crew on orbit. And so this is demonstrating for us Robonaut's ability to do simple kinds of tasks that you might be able to offload from the crew onto the robot. And they're the kinds of tasks you would need both to have Robonaut work inside the crew volume, but also to go outside and start working outside the ISS and be able to cover some tasks that today we would have to do with a spacewalk. In Expedition 33 and 34, we'll continue these kinds of task board operations. We'll also be incorporating more vision and additional automation capabilities so that Robonaut is making a few decisions on its own and then using a set of guidance, and then we can demonstrate that those decisions are good decisions in completing tasks without having quite as much specific control from the ground. We'll see teleoperation and checkout and new commanding tools. All of these are moving us forward to more independent intravehicular task demonstrations, more complex things than what you're seeing now, and then eventually toward being able to bring a test article outside of the vehicle and have Robonaut do a spacewalk in the future. I'm not going to have time today to talk about some of our Earth and space science results. The alpha magnetic spectrometer, for example, is still collecting data. They're up to 19 billion observations. They're collecting data at a rate of about 1 billion per month. So there's a lot of other things going on that I won't be able to talk about today. But I wanted to close my remarks because of the passing of Sally Ride this week and talk about her project on the International Space Station, EarthCam. EarthCam is an educational project where students, middle school students, learn about the Earth. They even learn about orbital dynamics. And they take pictures of the Earth by writing commands, selecting targets. And then university students do the mission operations to control a camera on the International Space Station, actually acquire those images and return them to the students. It began originally as the KidSat project back in shuttle flight STS-76. It rapidly grew. In 1998, it was so successful, it was renamed EarthCam and started preparing to be an ISS-based investigation. And it's been on ISS pretty much since the beginning of our assembly. It started its first operations on ISS in 2001. And to date, over 190,000 students have taken over 45,000 images. There's even an ops controller in mission control today that began her career as a university student helping with EarthCam control from the Mission Operations Center at the University of California, San Diego. I just wanted to personally mention some of the impacts that I see from Sally Ride's life. I look around at NASA and my own work group, and when you compare that to what things look like during Apollo, I think you really see that influence. So in my own team of scientists and engineers, we actually have more women than men today. That's a huge contrast from what things look like, say, when I was in chemistry class in the 1980s and I would be the only girl in the class. And that change, having that kind of a figure, has transformed girls' lives, both from seeing her as a model and then also from some of these specific projects like EarthCam and like Sally Ride Science. I've had the opportunity to take my own daughter to a Sally Ride Science Festival and see how excited girls get about science by having things accessible and fun and by seeing models of women who have been successful scientists. And those girls now today don't even realize that there was ever a time when women weren't commanders of the space station, when women weren't commanders of space vehicles, when women weren't scientific leaders and engineering leaders. And so I am definitely going to miss Sally's presence in the world, but that legacy is one that will be with us forever. So with that, let me hand back to our moderator for questions.
Thank you, Julie. Those thoughts are greatly appreciated. And one point of clarification on Dan's opening remarks, so many vehicles, so many datelines, so many time zones. The Progress 48 cargo ship launch coming up next week is on Wednesday, August 1st, U.S. time, August 2nd, Baikonur time. and we'll talk about our coverage plans at the end of the briefing. So with that, we're ready to take questions here in Houston. Mark in the back. We have the mics up above your head, no problem.
Yeah, thank you very much. I think I have a couple for Dan Hartman, if I've got this directed correctly. Can you talk a little bit about the 47 progress redock and just I gather the station mission management team sort of went over the sequence of events today, and were there concerns over any sort of safety, or is this pretty benign if you run the self-test and it fails at a certain distance, there's not really any sort of a collision threat?
Sure. Mission management team did talk at length this morning, and I think there's still some follow-up discussions. I would say going in, it is recognized by both sides, us and the Russians, quite honestly, the whole partnership. We're going to follow the flight rules. Okay, so what we need to be in place will be in place when we implement this. When they get to the 45, 46 kilometer check, you know, if range and range rate are within the specifications allowed for a typical course, we don't see any issues on pressing forward. So, in fact, the folks from Energia that we talked to this morning, I mean, they basically said that as well, as safety is their #1 priority in doing this. They are very interested in obviously conducting this test and seeing the results off this new avionics box, which would, you know, subsequently go into potentially downstream missions as an upgrade. If they are successful bringing in the 47P, I would imagine they'll try to dismantle and take that box out, because obviously it did have some issues, and then we'll probably bring it home on some subsequent mission for them to do additional troubleshooting. But you know, real time, you know, as in any docking berth event, there's a lot of real time work that goes on as well, right? But right now, we're going into this with every intent. We're going to follow the flight rules and bring it in safely.
It's an interesting project. Same could probably be said with the 48 progress launch plans and the one-day launch to dock scenario. Could you sort of talk about where that might be going? I realize it's a Russian project, but it's a little bit difficult to get, you know, because we're so far apart to get their perspective. But what's in store that helps the space station down the road if this comes off?
Sure. And I know Chris is prepared to talk some of the specifics as far as the orbital dynamics, if you want to get into that aspect of it. But they're looking to eventually take this into the Soyuz phase, right? So, in my mind, from what I've heard in discussions with them, it's a crew comfort. If you can get the crew to orbit in 6 hours and on board the International Space Station, that could be a tremendous benefit than over, you know, the 2+ days that it takes today. You know, I think they're able to take out a spin rate, which is involved in the longer duration Soyuz missions, and so I think that's their ultimate goal in trying to do this.
Thank you.
Robert?
Robert Perlman with Collect Space. With questions for Dan, I think Chris as well. Just to clarify something you just said, if the Kurzine test retest does not go as planned, you'll still bring the progress into dock using the old Kurz system?
No, if it fails that test at 46, it'll do an abort, and it'll be done, and it'll be on its secondary payload mission, and then re-enter 4 or 5 days later, I think, is the plan. So we'll be done. If it fails that test, it's over. They won't, and because again the 48P coming in, there's really not an opportunity to try to bring in, have another attempt, let's say.
And are there any concerns or connections? I know they're two different systems, but where this test would have an impact on the four-orbit rendezvous test going forward?
No, this is a kind of a one-of-a-kind box that flew on this NA. The 48P Progress has the existing course systems that tried and true form.
And then, since it was mentioned, Christy, you could talk a little bit about the orbital dynamics. What makes this upcoming 4-orbit rendezvous what makes this possible now, and why is it just being introduced now? And does this have potential to be applied to American vehicles as we move into commercial use?
Sure, Robert, I'll be glad to give you some of the background. As Dan mentioned before, the benefit obviously is the quicker rendezvous that you have, the less consumables you would need for the first day, and the better crew comfort on a small capsule. So as we move from shuttle with big volume to smaller commercial vehicles, capsules, we'll have the same issue as the Russians, where we'll want to minimize the amount of time that the crew spends in a small volume, minimize the amount of food and other supplies that they would need for, instead of doing a Flight Day 3 rendezvous, if they can do a Flight Day 1 rendezvous. And this is actually old technology. Our first ground-up rendezvous on the Gemini program was a Flight Day 1 rendezvous, and the Russians have done this before, so it's sort of back to the future. Now, it does impose more constraints on the geometry, the orbital mechanics of the launch, because you have less time to catch up to the space station. You've got to basically launch and be in the right spot, and the space station has to be in the right spot. We refer to that as the phase window, and so there's a very strict limit on that phase window for a Flight Day 1 rendezvous, and those conditions will exist this coming week when the Russians attempt the 48P one-day rendezvous. The conditions repeat themselves every 3 days with the current altitude of the space station. So again, that's the kind of thing that the trajectory specialists in Houston and Moscow have to closely monitor and make sure that they set up the right initial conditions to support this kind of rendezvous. And that sort of explains why we haven't done this a whole lot in the earlier phase of space station, because it does require a bit of overhead in terms of the management of the trajectory.
Thanks.
Questions? I don't think we have any questions at other centers, but we have two reporters on the phone bridge, and I believe we start off with Marcia Dunn of the Associated Press. Marcia, you out there?
Yes, I am. Can you hear me?
Sure can.
Yes. For Dan or Chris, I'm wondering, looking ahead to the next SpaceX launch, what lessons were learned from the successful May flight? Any changes that are going to be made, or any improvements, and also along those lines, the payloads that you will have on board, will there be any one-of-a-kind irreplaceables or not?
Okay, I'll let Julie be thinking about the payload question. As far as major lessons learned, they did have some issues with the LiDAR and the thermal imagers, and I know they've been working through those. Major modifications, I don't follow it as closely as a lot of others, but I think just primarily in the areas of a few software upgrades and improvements. And so as far as changing out major components on the vehicle or based on demo from this, I haven't heard of anything. And so and if you look back at the demo performance, it was outstanding. And so maybe not. Don't change a good thing kind of thing. So like I said, I do know they are making some software upgrades, probably try to improve some performance margins, things like that. But overall, no major changes that I'm aware of. And Julie, on payloads?
Sure. On payloads, we're really treating the next SpaceX flight as a nominal flight. There are going to be a number of unique things going up and unique things going down. But people sometimes misunderstand that. For example, many biological samples that are in our freezers on ISS, they're actually degrading over time, even though they're in the freezer. So they're absolutely priceless samples, and if we don't bring them home, they'll become worthless on ISS. And SpaceX, for us, is a really important capability for bringing home those kinds of samples. That's especially important for our national lab users in biology and biotechnology, where a lot of that research is located. So we're really excited about the flight. We're happy to see the results so far, and we're getting all the kinks worked out in how to handle those sensitive samples. Yes,
for Julie, speaking of payloads, weren't there some issues with some of the student experiments on board? They didn't get activated or something. Could you comment on that? And are you seeing a lot more interested parties who want to send things up to the space station for research now that they would have a way of getting them back?
To address your first question, there was a set of student experiments that were essentially activated like a glow stick is, where you bend the stick and you hear a crack inside. Unfortunately, when the crew was given the procedures, it was left out that they should listen for that crack. So they bent them the amount that was shown in the video, and they didn't know that they needed to wait for a crack on that. So that was one of those things that sometimes happens with a brand new experiment. There was a little bit of mispress out there because the students were disappointed, and at first we didn't understand exactly what had happened. And we'll just fly it again. The beauty of the space station compared to the shuttle is that when something goes wrong, you just do it again, just like any other laboratory, and things go wrong in the lab all the time. So it's really not a big deal, and they'll just have to wait a few extra months. In answer to your other question, we just had a big ISS Research and Development Conference in Denver at the end of June, and it was amazing to see the number of new users coming forward. CASES has their first announcement of opportunity out on the street, and a large number of different types of users that are not traditional users of ISS are expressing interest in using ISS as a national laboratory. So we're already working hard on the program side to try and plan ahead and make sure we get ahead of the capacity demands, because we're seeing a lot of new work coming in.
And if I might ask a quick spacewalk question, for the next two spacewalks, who are going to be performing those on board? And I wasn't quite clear on what the U.S. job is going to be on the U.S. walk and what's going to be done.
Can you handle? I can handle the task. I'm not quite sure.
Let's see, for the, yeah, I'm not sure which Russian crew members will be doing the Russian EVA.
And MALENCHENKO, Chris.
Okay, thank you, Rob. And for the U.S. EVA, it will be Sunny and Aki.
Let's see, Marcia, in the tasks, right? So the MBSU 1 R&R, we're going to perform that. Again, the box is performing as far as distributing power across the station loads outside on the truss, but we've lost kind of command and control insight into the box. So it's kind of like, the circuit breakers have stayed closed, but we're basically lost any inability to understand if any changes are going on. And so, if we had a hiccup upstream of that would trip the box off for whatever reason, we would not have the ability to command that box on. And so that's kind of our vulnerability there. So we're going to go get after that task. It's, I think, a couple hours of part of the EVA. We'll also be laying in some MLM power cables for when the MLM shows up in December of next year. And we're also going to be putting a cover on PMA-2 forward, which is where the orbiter berthed or docked. We're going to protect that docking ring to support our future commercial crew vehicles that will be coming up. And so just, again, a cover to protect the seals and the infrastructure there.
Thank you. And if you could repeat the two cosmonauts who are going to be doing the spacewalk, I didn't hear you, Rob. And will this be the last of the debris shields to be put on the Russian side, or are there more to come?
Yeah, the two cosmonauts for the August 20th Russian spacewalk are Gennady Padalka and Yuri Malenchenko. And I'll let Dan talk about it.
Yeah, Marcia, my understanding is these are the last set of debris panels for the SM.
Thank you very much.
Mm-hmm.
And we're going to have a comprehensive spacewalk preview briefing here on August 14th at 1 p.m. Central Time to preview both the Russian and the U.S. EVAs. I think next up on the phone bridge, Denise Chow of Space.com.
Hi, thanks. Actually, just a couple of clarifications. If the Cygnus does launch in December, does it also dock to the Harmony node?
Yes, that's correct. It will dock to the same port there on Harmony, the Node 2 module, the Earth-facing port that SpaceX also uses, and that the HTV uses for that matter.
Okay, great. And also, with the pace of the visiting vehicles, the schedule that you just outlined, once the commercial vehicles, both of them, the Dragon and the Cygnus, come online, are you expecting that schedule to increase significantly, or because there are more vehicles, it'll be spread out a little more? Thanks.
I was going to say, naturally, we work all the visiting vehicles in with the HTVs, the ATVs, Progress, and we purchase a certain amount of upmass. We try to lay in these vehicles, honestly, when they're ready, as well as when we have a need for them. And so, and when I say need for them, a lot of that in the future will be driven by some of the research that's critical to get up and back. And so, they'll be becoming major players into when these vehicles launch in the future. But they're typically evenly spaced out, so we have a good resupply, and even if we had an incident on a mission, we can skip and pick up with the next one without too much impact. That's always kind of our game plan.
Okay, I think that's all the questions on the phone bridge. Any follow-ups here? Mark?
Thanks. I'm not sure what this is for Chris or Dan, but when the 47 progress is activated for the self-test for the next docking attempt, is it behind the space station? I'm just wondering what the relative position is when that's conducted.
Can't answer that. I can tell you they're on their, I'll put it this way, they are going to be following their normal flight plan of how they bring in the progress.
Yeah, and the 47P vehicle is currently located in front of station, so they will be rendezvousing from in front. I think they're about 400 kilometers out in front, making way for the Japanese HTV to come in and rendezvous from behind, a normal type rendezvous approach. And then the progress vehicle will be approaching from in front and above the station. It will transition to behind the station for the rendezvous, but I'm not certain where it will be relative to the station when they activate the course system.
Robert. For Julie, you mentioned 198 experiments or investigations going on. Is that full capacity for the space station, or can you give some sense of maybe by percentage, or are you half full? Do you have a waiting list of science waiting to go up, or are you soliciting more?
Right, so you can measure the capacity of the laboratory in a couple of different ways. Basically, our crew time is full. You heard Dan mention that for the U.S. operating segment, that 35 hours a week for our 3 out of the 6 crew members is our full capacity, and that's totally booked. So experiments that are crew time intensive, there is starting to be a slight wait. Now during assembly, for example, we had waits for up mass where experiments waited on the ground. That's completely gone. So our up mass is not limiting at all. We can also look at our capacity in terms of the on-orbit real estate. Is there a place to put your facility or the hardware that you need to do the experiment? And when we measure the capacity that way, we're at about 73% capacity. So there is some room, and that's really important to ensure the success of ISS as a national laboratory, is to have some space for new experiments to come in with all of the interest that we have.
Okay, I think that wraps up all of the questions. A couple of programming notes before we close in this busy period for the station. Tomorrow morning, we'll provide live coverage in 2 broadcasts of the grapple and berthing of the Japanese HTV cargo craft. Our grapple coverage on NASA TV will begin at 6 a.m. Central Time, followed by berthing coverage at 9:30 a.m. Central Time. On Saturday night, we'll return to the airwaves on NASA TV for coverage of the next docking attempt for the Progress 47 cargo craft. Coverage will begin actually in the late afternoon Saturday at 4 p.m. Central Time, 5 p.m. Eastern Time. Assuming Progress 47 docks to the station, our coverage of its final undocking will take place on Monday. The exact time of that final undocking is currently being discussed by the program and Russian managers. And finally, next Wednesday, August 1st, we'll provide live coverage of the launch and docking of the ISS Progress 48 cargo craft, launch coverage beginning at 2:15 p.m. Central Time, and docking coverage that same day beginning at 7:45 p.m. Central Time on Wednesday evening. So it's a busy period at the International Space Station. You can follow all of it with us here on NASA TV and on the web at www.nasa.gov. Next up, the Expedition 33-34 Crew News Conference with Ford, Novitsky, and Tarelkin at 1 p.m. Central Time. Until then, thanks for joining us and have a good day.